Hello everyone, my name is Callum and welcome to the first video in the devlog series for my mobile game, Forward. Now, as this is the beginning of something new, I'd like to take a moment to explain to you my plan and what you should expect from this series. I will make a devlog each week or fortnight where I will be outlining my process, some of the things that I've learnt, the plan for the following weeks, and ask for your feedback and suggestions. As future updates are considered, I will create a trailer of sorts that will start the next series of devlogs associated with the progress towards the desired update. I plan to have this current series finalized by the end of January alongside a free release on the Android platforms. So you may be asking yourself, what is Forward? Well, put simply, Forward is a mobile game on Rails that was made by me for a university brief at SAE Institute in 6 weeks. The game is set in software, and you are a virus that is trying to infect as many computers as you can while avoiding the antivirus robots. You do this by moving left and right to dodge incoming enemies and projectiles. As you complete levels, you have the chance to get one-time use abilities, which gives you an extra edge when you need it. Your health is your movement speed. If you get hit by an enemy or its projectile, you'll lose speed. If you come to a standstill, you'll lose the level. However, if you make it to the end, you win. There are multiple stages with unique themes that can be unlocked by completing the levels of the previous stage consecutively without losing. One of the biggest improvements that I made to the project was the level generator. This is a backend system, however, an important one that increases my process efficiency dramatically. After making a handful of changes to a level by scaling and positioning cubes manually, I knew that I needed to figure out a better solution. I started by creating a buggy mess of a class that would instantiate cubes in a specified direction relative to the last instantiated cube. I mapped this to the numpad keys 4, 8, 6, and 5, however, this process was still too slow. Furthermore, there was a lot of unnecessary rendering of internal faces and a large component overhead from excessive amounts of wall instances. This tanked performance on lower-end devices, making the game unplayable. To address the inefficiency of the first iteration, I took inspiration from Brackeys and used a color to prefab system. This involved reading pixels from an image and instantiating them in 3D space relative to the pixel coordinates. I used Blender to create a handful of different mesh that rendered select faces and used them as wall prefabs in Unity. The problem with this, however, was the excessive cognitive load required to remember what color was associated with what wall mesh. It ended up being a slow process trying to understand what color to put for the correct orientation, not to mention we still have the excess component overhead. The final iteration solved my efficiency and optimization issues. I still used the color to prefab system, however used a single color to represent walls and variants to represent enemies. The class would generate a single optimized mesh that would be used for the mesh filter, mesh collider, and would only need a single instance for the walls. This removed unnecessary rendering and component overhead, increasing performance by above 65%. I would need 2 images for this to work, one for object placement and the other for object orientation. I used a combination of Unity documentation and a resource I found online to understand how mesh generation works in order to achieve this. Let's have a look at some of the key functions and what they're doing. First, we are marking a bool array called voxel map based on the map data we feed it. This essentially keeps track of the 3D positions that should have a wall. So you can see in this for loop, we are storing the color value of the X and Z position, or the map width and map depth coordinates, on the object image. This reference is then used to determine if the voxel map at the current Vector3 iteration should be marked as true. We then run the createMapObjectData function, which is another Vector3 for loop similar to the previous one. This simply feeds the position through the addVoxelData to level function if the map image allows it. I'm going to call this AVL from now on, just so I stop twisting my tongue. Now, at first, you may think that these two functions could be refined into one. However, that would cause us some issues, which we'll get into shortly. The AVL function simply checks if there is a voxel in all of the directions around it. If there are no voxels marked as present, it generates the vertices, UVs, and triangles in that direction. This is why the populate voxel map and create map object data functions must be separate. If we were to generate a wall in tandem with marking the voxel map, the script has no way of knowing if there is supposed to be a wall in any of the surrounding directions. Finally, the vertex, UV, and triangle lists are converted into an array and stored in a new mesh. This is then applied to the mesh filter and mesh collider components. That's more or less how it all works. If you want to learn more about the system, there will be a link to the tutorial and resource I used in order to get here, but stick around till the end of the video as there are some more interesting things to come. Naturally, the next step for me was to automate the setup process for the scenes and level selection system. Originally, it would take me roughly 10 minutes to set everything up between saving, manually placing objects, setting variables, etc. Now, it takes about 5 seconds with the new system. I simply give all the necessary data to the custom window and it sets everything up automatically. The most interesting part that is worth discussing here is how I created the custom editor window and instantiated a linked prefab within the Unity editor. I have never really worked with the Unity's custom editor classes before, however it was pretty straightforward once I understood the difference between GUI layout and editor GUI layout. Simply, GUI layout is for displaying information and editor GUI layout is for input fields. One thing that I will bring to your attention is the use of a drop-down menu to show different content. To make this work, I quite simply created an int variable called themeType and set its value to the result of the pop-up, which uses a string array as its reference point. Simply put, the theme label existing string is 0 and the theme label new string is 1. I then use the theme type values as the condition for a switch statement, which displays different editor GUI layouts. I also created a handy function here that lets me create a new theme scriptable object and store it within a consistent location in the project files, for efficiency's sake. This takes us to the scene generator class, which handles all of the setup. This process is very straightforward, however, one of the issues I experienced was the instantiation of prefabs. I found that if you use the object class to instantiate, it would not link it to the prefab instance in the project, meaning any changes made to the prefab would not be reflected in this instance. While this is fine for the level generator prefab, it's less than ideal for the player group object. Luckily, Unity has a handy class called prefabUtility where you can pass a prefab reference into it, linking it as if you dragged it into the scene yourself. While most of the time was spent on the level generator, I managed to implement speed regeneration. This is a pretty straightforward addition, however I added this as previous feedback stated that the permanent damage was too brutal and made the game too difficult. If we include this feature, I would be able to add it to the list of upgradable stats in the character progression system, and I could make the levels even harder as there is some sort of recovery. I would like to take this opportunity to ask you to leave a comment. What do you think? Should speed recovery be limited to abilities, or should it be a passive regeneration, and why? I was originally using the default character model, X, from Mixamo. However, this did not fit with the theme of the game and I wanted to create something unique. After looking at different types of computer viruses online, I decided to gather a handful of reference images for worms. I then went into Photoshop to sketch my idea. I was going for a sci-fi mechanical worm with emissive components and a hard surface design. I used inspiration from computer chips and sci-fi ships for texturing. I also described some of the expected characteristics of the character to better understand its structure. I then went over to Blender and modeled, textured, rigged, and animated the character. If you want to see the full time-lapse, you can check out the video separately. The link will be in the description and in the top right. So for next week, some of the core additions that I will be making are as follows. Create in-game currency, create another character, create a teleport and freeze time ability, and create another 8 levels, including an invisible tutorial, which should be an interesting topic to discuss. Thank you so much for joining me, and I look forward to the next devlog. It really means a lot if you've made it this far into the video, and it took me a little bit longer than I expected to create this one, but I learned a lot of valuable production skills and lessons, so hopefully the next one will be a lot quicker. And look, if you liked what you see, please consider leaving a like, subscribing, and sharing and leaving a comment. What was your favorite part, or what are you most excited about? Just get some engagement going, that would be fantastic. Make it your mission to learn something new today, and I hope you enjoy the rest of your day.